All right, as we move into 5.2, we're going to be looking at the use of intercepts with equations. Before we begin, we need to review a couple quick ideas. First, equations written in this format are called being written in slope, y equals mx plus b, are in what is called slope-intercept form. Now, that's one way we can write equations, but we're not going to use it as much in this section. What you want to be thinking about is ones written this way, ax plus by equals c. Now, that's standard form. Whenever possible, when we're talking about the intercepts, we want to talk about it in standard form. So file that away as a point we're going to be coming back to throughout this lesson. Now, when we talk about the intercepts, here's my axis. So this is my x and my y. It's like that. I'm going to go ahead and put a line on here. So we'll put it on, we'll do it in green. So there's my line. And it's going to cross the cross the axes twice. We call those points the intercepts. Now, an intercept is also noted by the fact that the coordinate, the ordered pair that describes it, will always have a 0 in it. So if I were to mark this off, 1, 2, 3, 4, 5, 6, 7, this is going to be the point 0, 7. It is 0 in the x direction and 7 in the y direction. With this guy over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is the point 12, 0, meaning it's 12 units left, right, 0 units up, down. We call those the intercepts. They're a good part of graphing that makes it a lot easier than trying to deal with finding the slope and doing other things. If we know the two intercepts, we can plot those 2 points and draw the line between them. If we're doing something that involves combining quantities, the intercepts represent where we have all of one or all of the other. So if I were to talk about this being something like apples and oranges, and I were to say that there's some rule that connects the number of apples I can have to the number of oranges I have, then one intercept means I have all oranges, and one intercept means I have all apples. So these are some applications of where the intercepts come into play as we use these formulas in the real world. Now, our first task, your first can do in this series, is if I were to give you a graph, can you identify its intercepts? So let me get some graph paper up here. Let's put some lines on it. So we're going to use this axis here. So there's my graph. And let's say I'm working with this line in red. There it is. Let me clean that up just a little bit. There. Now, can you identify the intercepts? Well, when I look, the intercepts are the places where the line crosses the axis. So in this case, I would say that the x-intercept is going to be down over here. And if I count off that point, 1, 2, 3, 4, 5, it is -5, 0. I can see that it crosses the x-axis right there. Now notice for the x-intercept, my y is 0. When I talk about the y-intercept, where it crosses the y-axis, this case, my x is going to be 0, and my number, 1, 2, 3, is going to be in the y part of the ordered pair. So my y-intercept, 0, 3. And that's all you need to do with this. If I were to do another one now, let's do a green line. Keep my black marker. Let's bring out my line tool. So say I've got one looks kind of like that. So let me clean that up. So it lines up a little better. So there, and maybe there. Okay, close enough for our purposes. So I've got an intercept here and an intercept here. So that means I would be looking at my intercepts. An x-intercept at, let's see, the x-intercept 1, 2, 3. So 3 comma 0. That's that point right there. And a y-intercept, which is happening at 1, 2, 3, 4, 5, 6. So my y-intercept is 0 comma 6. So we're looking at the graph. You're looking for the point where the line crosses one of the two axes, the y-axis or the x-axis. Now this changes if we don't have a graph to look at and we're simply looking at an equation. So I want to do 2 of those with you as part of this review, so when we come into class we can begin practicing these skills. Now, if it's given to you in standard form, so say I've got this equation, 3x minus 2y is equal to 6. There is an equation in standard form. We know it's a line and a linear function because it's written in standard form, and that was one of our tests. If the equation can be written in standard form, then it's a linear function. Now, when I go to write my intercepts, what I'm going to do is say, for my x-intercept, so for my x-intercept, I'm going to consider that y must be 0. For my y-intercept, I'm going to assume that x is 0. So what I'm going to do is use those in order to calculate what the other guy has to be. So let's do some calculating. If y is 0, then I'm looking at 3x minus 2 times 0 is equal to 6. I'm substituting the 0 in for y. Now, something else you'll notice, that drops out. So now I'm looking at 3x equals 6. Divide both sides by 3, x must be 2. Which means my intercept must be 2 comma 0. Remember, if x is 2, it's the first number in the ordered pair. First number in the ordered pair. X is the first number. Let's see what it does with that. Yeah, I'm not going to do that again. Let's clean that up. Bye-bye. There we go. I said it, I don't need to write it down. All right, now let's do the algebra. Let's talk about y. X is 0 this time, right? So 3 times 0 minus 2y is equal to 6. 3 times 0 minus 2y equals 6. There, should be happy with that. Thank you. Now, in this case, you'll notice that the x part drops out. Watch your signs. This is negative 2y is equal to 6, which means when I divide both sides by negative 2, I get y is equal to negative 3. You really want to be careful to be sure you're still going to have those signs. That negative 2 hung around. So now my ordered pair, 0 comma negative 3, and I have my 2 intercepts. If it asks me to go on and graph from this, I can still do that. Let's get my axis in front of me. So there's my axis. I'm going to plot my 2 intercepts. 2, 0, 1, 2, and 0, negative 3. 1, 2, 3. Now I can go ahead, draw my line, and I'm done. I've drawn a graph without making a t-table, simply by finding the 2 intercepts, plotting them next to each, and plotting them on the graph. I guess you could say I made a t-table. But with those 2 points, it's enough to draw a line. That's what you want to be looking for, is a chance to do just that. Now, the key to this is, again, I had it in standard form before I found my 2 intercepts. So use that as a tool to help yourself out along the way. Now, let's take a look at least one more of these. All right. Now, what happens when the equation we're handed isn't in this nice, neat standard form for us to play with? So let's say we even start with one that's in slope-intercept form. We're asked to find the 2 intercepts. So y is equal to 4x minus 3. So that's what we're looking at. Well, the first thing we're going to do is turn it into standard form. So I'm going to subtract 4x from both sides of the equation so that it is in standard form. So there's my 4x to take away from each side. And when I clean it up, I'm left with negative 4x plus y is equal to a negative 3. Excuse me. Now, I've got it set and ready for me to go ahead and find those two intercepts. So what I'm going to do is I'm going to replace remember, for the x-intercept. So for the x-intercept, we know that y is going to be equal to 0. It's always the other one. So I'll put that in. So negative 4x plus, 0 equals negative 3. So that now gives me negative 4x is equal to negative 3. And then I can say that x must equal negative 4. Nope. Divide both sides by negative 4. So I'm going to have this. X is equal to a negative 3 over a negative 4, which is a positive 3/4. Meaning, my intercept is going to happen at the coordinate 3/4, 0. That would be my x-intercept. Now my y-intercept is where x equals 0. That's my y-intercept. So we plug that in. Negative 4 times 0 plus y equals negative 3, which means, that drops out. Y is negative 3. I'll put that negative in a second. And I'll put that negative in there because it's a negative 3. So this is going to be 0, negative 3. That would be my y-intercept. I now have my two intercepts. Remember, the intercepts represent the points where I have all of one or all of the other between the two quantities I'm juggling. I've got two variables. I've got all of one variable or all of the other. If I were to do a graph of this, so we'll make a little grid graph paper over here. It looks like I'm going to be at 0, negative 3, 1, 2, 3, and 3, 4, 0, 3/4. There we go, 3/4 is 0. So this would be my line. And there's my line. All right, when you come in, we're going to be diving into more of these and applying them to some story problems as we wrap up 5.2 and get ready to start talking about 5.3. Have a good one.